All right, I'm going to get the show on the road. Hope you're doing well today. Welcome to another rendition of Zephyr 101. I'm Jared, and we're going to be talking about creating a Bluetooth low energy service in Zephyr. So that's the deal. That's what we're doing. If you haven't already subscribed to the channel, hit that like button, hit the subscribe button, leave a comment down below. I'd love to hear your comments, suggestions for future episodes of Zephyr 101. So, and speaking of, here was a comment from a couple episodes ago, and I wanted to dive in a little bit further on Bluetooth. Paweko Kwa 44, I would love to see some how-to when it comes to BLE. So that is what's going to happen today. So Bluetooth has some predetermined services and characteristics. You can, of course, use them. Those are like the heart rate monitor service, the so on and so forth. So there's a bunch of examples. There's other ones that are becoming more adopted, like the Nordic UART service, things like that. So, but they're often not enough for our purposes when we're creating something custom. So Zephyr allows you to not only use those other services, but also create your own service with some custom characteristics. Now think of if you're new to Bluetooth, think of a characteristic as an endpoint where you can access a certain piece of data. So for instance, in my example here is I created I'm using the air quality wing, which is measuring 4 different points of data. So for every point of data that I'm taking, each of those pieces of data gets their own characteristics. So we're talking about temperature, humidity, PM 2.5, and VOCs. So that's the idea, is to separate those out. You can kind of format it however you'd like. You can create just one characteristic, one service, and you can read all those pieces of data maybe in a format like JSON or CBOR or whatever. It's really up to your imagination on how you want it to work. What we'll be doing is I'll be reviewing how I created the kind of air quality wing BLE service, which you could connect to with a phone or maybe another central device, maybe like an NR52 acting as a central. There's a couple different ways you can do it. So one thing that I did in this sample that I thought was a little bit different than other ones is that I actually used an configuration or CMake list actually added an overlay for the BLE.conf. So sometimes you can kind of just put it in prj.conf, but maybe if you want to separate it out just for readability purposes, you can always do that as well. So this is my main CMake list for the sample itself. This is enabling and configuring Bluetooth, configuring SMP, which is essentially the functionality allows you to do over-the-air updates over Bluetooth Bluetooth settings. So if you want to store any type of configuration data or pairing data, this allows you to do that. If you don't have this enabled, then you're going to be out of luck. And every connection will be set up from the beginning. Enabling peripheral. So if you want it to run in central, you can always enable the BT_central equals yes. Or if you're in peripheral, you can do what you can see here. You can also do both. So you can actually have a Bluetooth device set up as central and as peripheral. And that's common across all Bluetooth, but that's just something to keep in mind. They essentially allow you to kind of prune out some of the things in the SDK that you're not necessarily needed if you're using one or the other. In this case, also setting a kind of static device name, which is just air quality wing. I'm going to gloss over these guys, but some of this is just configuration for SMP. This is I believe it was an older version of the SDK. I mean, some of this might be already enabled by default when you enable the SMP from the Bluetooth end. So I just kept that in there. You can check it out where it is in the configuration file in the link below if you want to really dive into it. But the main idea is like we're enabling Bluetooth, we're enabling peripheral mode, we're enabling some of the added functionality, kind of the niceties, allowing for OTA updates, device name. You can also actually update the device name dynamically during runtime if you want to. In this case, we're just doing it statically. And also settings related to pairing data and so forth. Here's some other important K-configs that you might want to consider or just think about when you're setting things up. I didn't have to do anything because it's kind of the defaults are fine for me, but the configuration for max connections. So if you want to set the amount of connections, maybe you have multiple devices that you want to connect to it. The more connections, the more memory usage you're going to have. So that's just something to keep in mind. Most of the time, one is the default. One is, you're only connecting to one phone or one other device. So then we get into more interesting things, features like extended advertising. Not only does this allow you to use coded PHY, which is essentially extending the range of Bluetooth, lower data rate, but higher distance. But you can also include a lot more data in your advertising, which is useful because regular Bluetooth low energy packets for advertising is 32 bytes. So you only have 32 bytes to work with, and that includes, if you're using a device name or something like that, that includes the device name. So you lose it pretty quick if you have a long device name. Periodic advertising, another feature that's great if you want to kind of save battery and you're actually reading important data that's coming off the advertising packets where you don't necessarily want to maintain an active connection to the device. So another option for you. This one is particularly interesting because we have a hardware defined MAC address. Essentially, you can always create these privatized addresses or randomly generated addresses when you're connecting. So there's no way if you're advertising, there's no way for someone to kind of sniff that data because it's publicly available. It's there. As long as you're listening for it, it's happening. Kind of prevents people from seeing your phone or seeing your device and kind of tracking it. So that's another handy little bit there. But there are a ton of Bluetooth settings and features. It goes beyond this. There's a lot of different niches and little things and rabbit holes you can jump down into if you really want to use the full functionality of Bluetooth. And they're constantly adding to the Bluetooth low energy stack and the definitions and the functionality. So a lot of this stuff is already built into Zephyr. Some of it, I know, for instance, if you have an Nordic chip, you're going to be using NCS, and NCS has some added functionality for Bluetooth, or you're going to have to use the NCS version of Zephyr because you're using a processor like the NRF53, which has 2 cores, or one is running the Bluetooth functionality. So all I have to say is it can get confusing, and there's a lot there. So now we're going to jump into the code a little bit. We're going to talk about actually setting the UUIDs for the service. So what happens here is we're configuring the service, and there are unique identifiers or UUIDs for every kind of aspect or part of the service. I'm going to turn that music down. Don't quite need that. And you can see it's kind of defined here depending on what SDK you're using. Like Nordic's previous SDK was literally just a string. In this case, it's actually just a macro. And this is actually going to be fed into another macro and then into another macro. So it's like layered macros. Lots of fun. But the idea here is we essentially, what I do and what I've seen is that you start with the service UUID, and then you increment that service UUID for every characteristic that you're going to be using. So if you dive in here, you look at the next one, and all I did was increment this guy to 2, and there are 4 different characteristics. So for every single one, I just incremented by 1. That way, it's kind of fallen underneath your service, and then it's easily accessible when you're connecting. You don't want to have the same UUID for different characteristics because it will not work. So just bear that in mind. I left out all the other UUID definitions, all the characteristic definitions to keep it simple because it just looked like a wall of text. So, but you can check out that it's in the AQW, it's under BLE services AQW.H, and that's just all the UUIDs to make it extra confusing. But once you do one, it kind of makes more sense. Then what we have to do is actually put it into a struct that we can use and consume when we're actually creating the service. So we've created these two defines, the service one and the temperature characteristic one. Another thing that is just defining for kind of public use in that header file is the publish function, and we will come back to that, but that's also there, so you can use it elsewhere. Here's probably the most important macro when it's related to Bluetooth and you're defining a service with characteristics. Now there's a bunch of macros that you can use to put in place. This is the most simple kind of format of setting up a service, a characteristics, and allowing it to be able to notify a connected device that there's been a change to a value that they're listening to. So we start with the primary service, and that is the AQW service, which we defined earlier right here. So those parameters are actually these macro defines right here. Then the characteristic, you're setting the UUID there. You're setting it to be like what you want it to actually do or provide. You can actually use it for reading. In this case, we're just doing notifications, and there are a bunch of other permissions and different statuses you can set depending on your situation. This one's very simple and straightforward. It's open. Anybody can kind of connect to this device and read to it. But if you're working on something where you want to be a little bit more secure, then you're going to be modifying these settings as needed. So this is kind of like baby's first configuration for Bluetooth service. And the last thing here is very important, is that GAT CCC. You want to be able to make the permissions for reading and writing for that guy, because that is that's essentially, so there's two characteristics that we're reading and writing from, or two characteristics that really matter for each data value. There's the number one, you actually have the data value itself. You can read and write from that. You can pull it essentially, like asynchronously. You can just pull it and see what the value is at any time. And then for notifications, there's a separate CCC characteristic that you're basically setting a bit on, and you're allowing it. You're saying, hey, I want to listen to any changes in this value, and it says okay, and then that's set up so then you can push to it, and it'll kind of notify the connected device. So without that, you can't have any type of notification. So it's definitely something you need for this. So we've set up the UUIDs. We set the stage to kind of how to publish. We're getting there. We've configured the service. We've set the proper permissions. In this case, it's very open, so there's not a lot of crazy things we need to do. And making sure that we add that CCC, I'm having a brain fart. What is it called? The client characteristic configuration, CCC. So one thing that got me when I started dealing with Zephyr and setting up characteristics is, how do I figure out, or like where to actually write the data? And one thing that you're going to run into is in order to write that data. So what that macro does is it essentially kind of allocates all the memory necessary for the operation of those characteristics. So we need to actually write to that memory that's allocated via that macro, but it's like, how do we get there? And essentially what we're doing is these are the positions of the data for the different characteristics. And this is going to become helpful because we're actually going to use them as kind of offsets to actually write to an attribute to set the data. It's weird, but hopefully you'll get it in a second. And hopefully maybe Zephyr, maybe they've already improved it, but it was not very straightforward when I did it a couple years ago. Now I get it, but for anybody starting up, it's definitely a little confusing. And even I've done stuff before in other SDKs, but it was a little odd for sure. So we must know the offsets, and the offsets is where, is where each characteristic was placed when we're calling that BT-GAT service defined macro. This is the actual publish function, and you can see the red arrow there. That is pointing to the position that we just defined earlier in that that position for the attribute for the data. So that this is kind of how we're getting how we're essentially notifying or setting the data in the characteristic at that for the particular sensor. That's a mouthful, but hopefully you get the idea here. So all we're doing is getting the pointer for the data that was allocated when we created the service. There are a bunch of different data types here, but I'm only focusing on just the one temperature sensor. And you can see then we're setting the params, so the attribute or where we're getting the data from, the data value, the size of it, and any other functions or callbacks or things like that, a little more advanced. If we go back here for a second. So all we do, that GAT attribute is basically making sure that we're selecting the correct characteristic, the correct characteristic from that service. Otherwise, it'll actually push to the wrong characteristic, or it might not update at all. So that's like the most critical part if you are updating values. I did run into that previously, is why when I wasn't using the right offsets. Yeah, I was looking at, I had it open on my phone. I was looking at the values. I'm like, why is the value for the humidity the temperature value? And it turns out I was just using the wrong offset. Finally, that last function there, the BT-GAT notify callback. So this is actually what's pushing that data and causing the API, the Bluetooth API, to actually publish the data to a connected device. And there are some caveats about that first argument, that null there, and I'll dive into that in 1 second. But so we've notified, we're notifying requires use of that struct. We've set the address of the attribute, so we know that we're actually publishing to the correct characteristic, setting the data and size as necessary, then calling the callback or the notification function that will allow us to publish. That function can be called without a specific connection handle. So in this case, it was set to null. So that first argument set to null. So it'll broadcast to all connected devices. If you have an idea, or if you have a connection handle, if you know what the connection handle is for your device, or you want to publish to a specific connection, then you can set up or use that handle, and it'll only publish to that one device, which is handy. You might have saw when I was referring to the creation of the service earlier, and that with that crazy macro, that a function callback was also used for the CCC configuration. And this basically allows you to see you can actually keep track of this in your code. You can do whatever you want with it. In this case, it was just a basic, is the notifications turned on or turned off, and then just printing out a debug message when it actually happens. So you can add, if I jump back to the creation of you can see that the BT-GAT CCC, that first entry there, that could be null, or that could be actually a callback function. In this case, it's just the callback function. So you can actually monitor what is going on, if something is actually a characteristic is actually being subscribed to or not. So it's just something to keep in mind. You can monitor, so for that particular thing is you can monitor when Essential is connected. You might want certain logic to happen in your code if it is connected versus not, or if the notifications are enabled or not. So this particular function is just simply printing out diagnostic information. You could always set it to null if you want to. Now we're jumping into more of the configuration and setup of Bluetooth overall. So we set up the service. That's good. But we're going to set up kind of advertising and just Bluetooth configuration overall. And because that macro is essentially called at the kind of more global level, there's no more initialization you need to do for that. It'll get set up at boot, and you'll have that access to that service, those characteristics. But there's some customization you can do. So here I'm setting the Bluetooth advertising data, setting up some default flags. We're using regular advertising. BR EDR is for regular Bluetooth, so we're just saying this device is not capable of any type of streaming audio with legacy Bluetooth. And we're also going to be advertising with the complete device name. So there's another option where you can do a shortened device name, so maybe like 5 or 6 characters. So it's completely up to you on how you want the advertising data to look like. This is the same struct that you can use to customize the data that is coming out of the advertising. So it's something to get familiar with and find it useful. I think either if you want to add your own custom data, I think it's just doing BT_data again and just doing your own custom data. But they don't have that in this particular sample. This should look familiar if you did watch the other episode on the NRF9160 plus the NRF52, combining the two. These are the same API calls for setting up Bluetooth. It's the same if you're calling it on a device that has Bluetooth built in, or if you're using the HCI UART implementation, same thing. You're using the same API. The only difference here is I'm not listening to the Bluetooth ready callback, which is the first argument in that BT enable function. So I'm just setting that to null, so you don't have to worry about that. If you want to pull any settings from the settings subsystem, you can call that settings load. Sometimes that's done elsewhere. So if you have other things going on the file system, sometimes you're loading that elsewhere, especially if you have other kind of important data that work with your application. I'm not sure if the SMP BT register is now required in newer versions of Zephyr, but in this particular example, we do need to register the SMP or basically the Bluetooth over the air the characteristic / service. So, and finally, we're finally getting to the last bits here, but if you want to advertise, you can call this BTLE advertise start. You're setting the advertising data. That's the data that I showed you earlier in that struct. And we're just making sure there's no errors or anything. And then we've called this setup function, and you're off to the races. Your device is advertising, and you can connect to it. And hopefully, fingers crossed, you can see the custom characteristics and service that you set up earlier. So that init function enables BLE. We don't care about the Bluetooth ready callback, whatever. It loads settings if they're enabled, register the over-the-air update functionality, and it'll start advertising. And you just call this from main once, and you're done. Now, if you have an application that maybe is a little more complicated, maybe you only want to control the advertising, maybe you want to turn it off sometimes, or you want to turn it on at a specific time, you have full control over that. You can call the, so very similarly with the start function, there's also a stop function, which will stop it from advertising. That's a great time. You turn it off, you update your Bluetooth, your advertising data, you can turn it back on. I don't know how friendly it is to update the Bluetooth data while it's advertising actively. I know I've had some issues in the past, so you're just going to watch out for that. In conclusion, the BLE can be pretty convoluted, hard to understand. It was crazy for me when I first started. I was like, UUIDs, I just want to access data. It's like a register, I just want to jump in. I want to pull out the data and see what's going on. But they made it so it's meant to kind of work with phones and work with other things, and kind of it's a standard that you have to collaborate across different devices. So it makes sense that it's a little bit more complicated to get started. But once you get the gist of kind of creating your own services and characteristics, it's not too terrible. So, but we've created a custom service for peripheral mode. We set up we're setting up UUIDs for the characteristics and service. We've configured it for notifications, so we're going to be kind of monitoring the data, and if data changes, we're going to get those updates as soon as possible on the phone side or central side, whichever you're connected to. And we set up advertising, so you can kind of see that, well, advertising is necessary for connecting to it. So that's another thing, is it has a dual purpose. You can advertise data from the device, and you're also advertising to hey, I'm here, I'm ready for a connection, And as long as you've configured it for connectivity, where something can connect to it and read the characteristics, then it'll allow that connection to happen. In this case, kind of by default, anything kind of can connect to this device and read the characteristics. So, but if you have something a little more complicated, there are some examples. So if you go to the code in the description, that's just the example that we've talked over today. There are tons of other samples in the Zephyr repository. If you go to Zephyr samples Bluetooth, there's central, there's peripheral, there's periodic advertising, there's codify, basically everything that you could imagine. There are uses of like the standardized services and characteristics. So that will get you really far if you're just starting out. If you just want to use something off the shelf, those samples are a really good starting point. If you want more, let me know in the description box below or in the comments down below, and I'd love to cover more if you guys are interested. But that is it for today. Make sure you jump over to ZeroWolf.com and subscribe to my mailing list. It should be right there on the homepage. I do send out a quick heads up update when these live sessions do come around. And yeah, I'm just really grateful for everybody being here. Thanks for watching. And I think we're good on comments. I think so. Well, I'm going to jump off. We've been on for good chunk of time, 25 minutes, pretty good, 27 minutes. And we'll be around for the next episode. So if you have suggestions, I'd love to hear from you. Otherwise, I'll have to think of some other interesting things we can cover on the Zephyr 1.1. So thanks for being here, and we'll see you on the next one.